In the next part, that is in question number 3, we are asked decimal expansion of a rational number cannot be terminating, non-terminating, non-terminating repeating, or non-terminating non-repeating. So what you need to remember that for a decimal expansion of a any number, right? Decimal expansion. The decimal expansion can either be terminating or non-terminating. If it is non-terminating, it can be repeating, also known as recurring or non-recurring. Well, if it is terminating, then we say it is rational. If it is non-terminating but repeating, then we say it is rational. The only condition when it is irrational is when it is non-terminating and non-repeating. So our question is cannot be, since it is a rational number, right? Since it is a rational number, it cannot be non-terminating, non-repeating, right? For a rational number. As you know, if it is terminating, still it is a rational number. If it is non-terminating but repeating, then still it is a rational number. And when do we say that it is irrational? When it is non-terminating and non-repeating. So we'll say that the correct option will be non-terminating, non-repeating. In the question number 4, that is fourth part, it says the product of two irrational numbers is always irrational, always rational, always an integer, and always rational or irrational. Let's say to figure out, I take two irrational number. I am taking a root 2 and a root 8. And I'm getting its product as we have to find out. So root 2 into root 8 is under root 16, which you know is 4. And clearly 4 is a rational number. So you might think that it is always a rational number. But when we take other examples, like say root 2 multiplied by say root 3, this is under root 6, which is an irrational number. So over here it is a rational, and over here it is irrational. So what we can conclude? We conclude sometimes rational or sometimes irrational. So we finally conclude that the product of any two irrational number can be a rational or irrational. In question number 5, it says the decimal expansion of under root 2 is it a finite, that means terminating, or is it 1.4142, non-terminating recurring, or non-terminating non-recurring? So what do we know for root 2? Clearly, root 2 is an irrational number, and irrational numbers cannot have finite decimal expansion, cannot be terminating like this. And if it is non-terminating, it cannot be non-recurring. As we know that for irrational number, it is non-terminating, non-recurring. Although when we write root 2 up to 2 decimal, we may write 1.414. Up to 5 decimal place, we can write like 1.41421 and so on. So it is non-terminating, right? So this is an irrational number. So it will be non-terminating, recurring, right? So we need to say this question once again. So we are asked to find out the decimal expansion of root 2. What we should know that for root 2, which is an irrational number, its decimal expansion will be non-terminating and non-recurring. In question number 6, we are asked which of the following are irrational. So we have to check out of these numbers, which of them are irrational. So let's do one by one. If I start with the first one, first one is under root 4 by 9. As we know, under root 4 is 2. Under root 4 is 2 and under root 9 is 3. So you can say its reduced form is 2 by 3, which is a rational. For this, I can rewrite this in a single under root, 12 over 3. And when we reduce, we get under root 4. So under root 4, which is equal to 2. So this is rational. So this is rational. We are looking for an irrational. What about this under root 81? You know, it is equal to 9. So this is again a rational number, so it cannot be. Finally, under root 7 cannot be reduced further. In the simplified form also, it is under root 7, which is an irrational number. This is question number 7. And in question number 7, we have to figure out which of the following are irrational. Now, one by one, we see that the first one here is 0.14. Well, clearly you should know that decimal expansion of an irrational number is non-terminating, non-recurring. So this cannot be the answer because this is terminating decimal expansion. When we look for the second part, it is non-terminating but recurring or repeating. So we say it is cannot be an irrational. Same as the third part or the C part, here it is non-terminating, recurring, so it cannot be irrational, it has to be rational. Finally, as we come to the D option, you can clearly see that here the decimal expansion is non-terminating and non-recurring. Therefore, it is an irrational number. So we say D is the correct option for this. In question number 8, we have to find a rational number between root 2 and root 3. Now, the first option is, but before that, we should know that if I write down the decimal expansion of root 2 up to say 2 decimal or 3 decimal place, it is 1.414. And for root 3, it is 1.732. That is up to 3 decimal place. Now we have to find out a rational number between root 2 and root 3. Now we know that a rational number must be has a terminating decimal expansion. So clearly we'll say that under root 1.5 lies between 1.414 and between 1.732. Now let's say why I discarded say option A here, because we cannot find an irrational number between two rational number as unlike a rational number like adding them and dividing. So is the case of product. That's not possible. 1.8 is discarded for the correct option because 1.8, the value of this is more than 1.732. That means it is more than root 3. That's why 1.8 cannot lie between 1.414 or between 1.732. So the correct option will be 1.5. We're now on question number 9, where we have to find the value of 1.999 in the form of P by Q, where Q is not equal to 0, and the options given are these are the options given here, that is 19 over 10, 199, 9 over 1000, 2, or 1 over 9. So you must be knowing how to convert a repeating decimal expansion in the form of P by Q. So first we assume this, let's say let X is equal to whatever the number given here, 1.999. We can write any number of 9 over here. Now, since you can see that only one digit in the repeating block, only one digit is repeating, that is 9. So in order to get the value, first we'll see that since one digit is repeating, we'll be multiplying 10 on both sides. So it is 10x. On multiplying 10, on the right hand side, you know that the decimal will shift one place right. So it becomes 19.99. I can write any number of 9. I choose to write 3 after decimal in each case. Now we'll be subtracting the first from the second. So 10x minus x is 9x. And if I subtract this from this, what we'll get 19 minus 1, 18, and rest is 0. So x is equal to 18 over 9. That implies if I reduce it further, we get x is equal to 2. So therefore, x is equal to 2 is the correct option for this question. In question number 10, we have to equate or get the value of 2 root 3 plus root 3. Now, for addition and subtraction of an irrational number, we assume these two we treat them as variables temporarily. Like I can write, if I ask you what is 2x plus x, right? Clearly you will say 3x. Same way, if I am asked to find out what is 2 root 3 plus root 3. Now, temporarily we assume these two and we treat it like a variable. And if I say this is 2x and this is x, you should say 3x. So similarly, 2 root 3 plus root 3 should be 3 root 3. And we can see that C is the correct option in this case. In question number 11, we have to get the value of under root 10 into under root 15. So I can say that under root 10 multiplied by under root 15 is equal to under root 150. Or I may write under root 10 into under root 15. Now, in order to write in the simplified form, I should split them into prime factors. I wrote 10 as 2 into 5 and I wrote 15 as 5 into 3. As you can see that we have a doublet of 5 here. So this 5, the square root of this will be 5 and we are left with 2 multiplied by 3, which is 6. Therefore, 5 root 6 is the correct option, that is option B. In question number 12, it says the number obtained by rationalizing the denominator. Now, first I'm writing the question here. It is 1 over root 7 minus 2. As you know that here the denominator is in the form of a minus b. So in order to rationalize it, we should multiply it by a plus, divide by a plus b. And if I do so, what you'll get here, 1 multiplied by this number will be under root 7 plus 2. Below you can see that it is in the form of a minus b and a plus b. So you know that a plus b, you should know the identity here applied. That is a plus b into a minus b is equal to a square minus b square. Therefore, I should write this as a square, that is root 7 squared minus b, which is 2 squared. With a further simplification, we can say numerator should be as it is. Root 7 square is 7, right? And root 7 square is 7 and 2 square is not under root 2. It's 2 square is 4. And finally, we can say that it is root 7 plus 2 and 7 minus 4 is 3. When I look into for the options here, I get A as the correct option for this. Now in question number, now we have reached question number 13, where we are asked to figure out with this 1 over under root 9 minus under root 8 is equal to which of these options. As we can see that all our options, we first must write down in the standard form, that is after rationalizing the denominator. So when I see the question, I say that our question is in the form of 1 over a minus b. In such a case, as I explained in the previous part, that we'll be multiplying with a. If it is in the form of a minus b, we should multiply divide by a plus b. That is under root 9 plus 8. With further simplification, we say it's under root 9 plus under root 8 because it is multiplied by 1. And below you can see it is in the form of an identity, that is a minus b multiplied by a plus b, and that is equal to a square minus b square. So what should I say? That this will be under root 9 square plus under root 8 square. Now numerator will be as it is as of now. And denominator root, oh, this is minus, right? A square minus b square. This is minus. Under root 9 square will be 9 only, and my 8 square is 8. Now, when we look into this further, we say that 9 minus 1 is 8, and 9 minus 1 is 9 minus 8 is 1, and 1 in the denominator we don't generally write. But when we compare with the options given here, we say none of them is equal to this. But wait a second, we need to further simplify it. As you should know that under root 9 is nothing but 3, and under root 8 is 2 root 2. Therefore, 3 plus 2 root 2 should be the correct answer for this. That is option D.